Thank you. So first, I'm very happy to be here. It's my third time here in 2025, but it's always a pleasure to come here. So I'm very happy. Okay, so today I'm going to talk about a joint work with Johan Taflin, which is to be written yet still. So I will just mention a part of this work, and it's related to the Bogomolov conjecture. So I'm going to start with recalling what is the Bogomolov conjecture. So we start with A, an abelian variety, over a number field. And so we endow it with a symmetric and ample line bundle. And to this data, we can associate a Néron-Tate height, which will be defined as a limiting process. So it's the limit of the, let's say, A veil height associated to this line bundle on A. And you plug in the multiplication by n, you divide by n squared, and it gives you, it converges. It gives you what we call the Néron-Tate height. On Q bar point of your abelian variety. Okay, so this height has a certain number of properties. So the first one is that it takes non-negative values, and at a point P, it takes value 0 if and only if P is torsion. And so the Bogomolov conjecture is about higher dimensional subvariety which satisfies somehow this property. So the conjecture of Bogomolov, and which has been proved by Ulmo and Zhang. So we take X to be an irreducible subvariety. Divide over Q bar. And you want to understand what is how can you characterize subvarieties for which the essential infimum of the height on the subvariety is 0. So here, let me remind you that this is the supremum of a closed subvariety of the infimum of the height of points which lie in X but outside of Y. So this is the essential infimum. And so the theorem is that this is equivalent to the fact that X is a torsion translate of an abelian subvariety. Of A. Okay. So the perspective of my talk is to do dynamics, and so this doesn't really tell you anything about dynamics. So let's formulate it in a dynamical way. So you can formulate it this way. It means that X is preperiodic under multiplication by 2, for example. So what do I mean by that? So it means that there exist integers such that if you iterate n times the multiplication by 2 x, it gives you the same as if you iterate n times and apply it. So under iteration, it goes back to itself as a set, okay? The action on it is not trivial, but as a set, it goes back to itself. Okay. So for me, this is a statement about dynamics, at least this part. And so you can ask whether you can have something similar in a more general setting. And so, what is the context in which we are going to discuss that? So what is the dynamical variant of it? So here you take x to be, let's say, smooth. It's not necessary, but simpler. Projective variety over a number field again. And you take L, you take F, a map from X to X, and you say that it is a polarized endomorphism if there exists L, ample, and an integer strictly larger than 1, such that the pullback of L by F is L to the D. Okay. So this is the setting. So example, X is an abelian variety, and F is a multiplication by 2. And you can take L any symmetric and ample line bundle. Then, so if you put back L, you have L to the 4. Okay, so this is really the same framework, somehow. So then you can use the same Tate argument to cook up a canonical height. So this is a height which is the limit as n tends to infinity. So here you have to take 1 over d to the n, and you take a vel height associated to your ample line bundle, and you plug in f that you iterated n times. And so this is on x of q bar that you have your height. Okay. So what are the properties of this height? Mm-hmm.
This d is the d over.
It's a degree. In dynamics, d is a degree. It's not a dimension. Yeah. It's like that. Yeah, it's the degree of the polarization. So if you wish, if you're just having x to be a projective space, it's just the degree of the homogeneous polynomials defining your map.
Thank you.
Okay. So what are the properties of this height? So the first one is that it's non-negative, and it's satisfied that the height of a point is 0 if and only if the point is preperiodic. So again, what does this mean? So this means that there exist integers for which the iterates, the nth iterate and the nth iterate of the point coincide. Okay. So we can say a little more about this height. Actually, you can characterize it quite simply. So by construction, this is your initial height plus a bounded error term. And it has some invariance under the dynamics, which is that if you apply it at the image of a point, you get d times this. Okay, so this characterizes the H. So this is the unique function on Q bar point which satisfies this property. Okay, and to show this implication, you just have to use that and the fact that D is not 1, it's larger than 1. And to show the other implication, it's that plus Northcott, essentially. Okay, so now what is the problem? So it's to characterize subvarieties Y such that the essential infimum in Y of the canonical height of F is 0. So can you do that? So if you look at what's above, you can say, okay, naive solution, it has to be preperiodic. No. No, it doesn't work. I have an example where it doesn't work. So it's cooked up from elliptic curves with complex multiplication. So what is the example? So you take E to be, yeah, my complex geometer side is coming back. No, it's over the complex. It's divine over Q, so it's okay. You take this elliptic curve, and you will look at X to be E times E, to be Y to be the diagonal in X. And what is the map that you are looking at is multiplication by 2 plus I on the first factor, and multiplication by 2 minus I on the second factor. So these are multiplicatively independent. So it's polarized. Sorry. So if you take L to be, you take any symmetric ample line bundle there, and you pull it back by the two projections, you get an ample line bundle, and this guy will have that. If you pull it back, you have, okay, yeah, to the 5. So it's polarized. Okay, and what are the preperiodic points? So P in X is preperiodic if and only if P is torsion in E times E, in this abelian variety. Okay. So in particular, this implies that the essential infimum in the diagonal is 0. Okay. But since these two maps, 2 plus I and 2 minus I, are multiplicatively independent, the diagonal is not invariant by this map. Okay. It's not preperiodic. It cannot be. So this is a counterexample. So this counterexample is not due to me. I think it's due to Gauthier. And so the conjecture took a certain time to find is, let's say, its good shape. And the final shape of the conjecture is the following. So it's, under this formulation, it's due to Gauthier, Tucker, and Zhang. So initially, Zhang's conjecture that it had to be preperiodic, that's it. And so this counterexample tells you it has to be a little more complicated. And so the essential infimum of the canonical height in Y is 0, if and only if, so if and only if you have another dynamical system which is somehow related to F for which your subvariety will be preperiodic. So let me formulate it more precisely, but you have to think about the fact that you have to find another dynamical system which relates to the map. Here, spoiler alert, it will be multiplication by 2. We're going to see that later. So there exists Z, a subvariety of X, containing Y, and there exists G from Z to Z, which is polarized also. There exists an integer such that the nth iterate of Z by F is Z, and the nth iterate commutes with G. So in this sense, it's related to F because there are not that many maps which commute with a given map. And there exists L in K such that G to the L of Y is G to the K of Y. So you have another map which is really related by this relation to F, for which you have the wanted conclusion. Okay, so in our example, what's going on? For the example, you take Z to be X, and you take G to be multiplication by 2. Then it's okay. Okay, and a little artificially, you can cook up examples where Z is really a strict subvariety of X. So, okay, it's not it's not just a comfort reason that we do that. There are examples. A little bit more complicated, but there are. Okay. So apart from the situation where you have an abelian variety, what is known about this conjecture? Not much. So what are the known cases? So the first case which has been investigated is the following. So known cases of the conjecture. So the first one is Gioca and Nguyen and Ye, where they study maps from a product of a projective space to product of the projective space, where you have rational maps of P1 acting diagonally. So F is given by Z1, Zn, sends to F1 of Z1, Fn of Zn, where the Fi act on P1, and the degree of Fi is the same for all I, is D at least 2 for all I. Okay, so in this case, the conjecture takes the simplest form, which is that if you take Y in P1 to the N with essential infimum 0, HF. This is equivalent to saying that Y is preperiodic. So, no, I did not do anything, sorry. Except for special F i's. So special, I won't spend much time about that, but these are the ones which come from an algebraic group. So Z gives Z to the D, Z gives 1 over Z to the D. The Chebyshev polynomials, which come also from the multiplicative group, and the ones coming from elliptic curves. Apart from those maps, this is the answer to the conjecture. Okay, and so this is in This 2018. Okay.
Just want to add a reference in there. The Mavrati, Schmidt, Wilms paper.
Oh yeah, you're right.
Yeah.
Yeah, to fill in a gap. You're right. Sorry. Yeah. And it's 2025, I think, just appeared. 4, okay. Okay. Okay, so the second case which is known is about maps on P2. So it's Dujardin, Favre, and Ruggiero. I think it's 2023, where they consider maps from P2 to P2. And you have to ask, so you choose an affine chart, and you impose that the line at infinity is totally invariant. So it's a polynomial mapping of the affine plane, from the affine plane to the affine plane, which extends as a regular map from P2 to P2. And you have to set up one condition. So you take C in P2 to be a curve, so irreducible again. And what you impose is that it intersects the line at infinity along points which avoid a certain property. It contains no pre-super attracting points. I'm going to mention what it means. So it means that if the points are preperiodic, then you don't want them to land on a point, on a periodic point where there is a critical point in the orbit. So you want to avoid that. Okay? So it's a very rare situation. And in this case, then the essential infimum of a C of the canonical height is 0, if and only if C is preperiodic. If this happens, we think it's not a problem, but their proof doesn't work. So, okay. Okay. So today I'm not going to give you a solution to this problem because we don't know how to solve this problem. However, I'm going to instead give you some results towards uniformity in this problem. So let me make it a little more precise. Ah, j'aime pas trop cette brosse. Okay. So what will be the context? So the context will be the following. So you consider the space of all such maps. So uniformity. So you let poly D2 to be the set of maps from P2 to P2, so that the degree of F is D, and the line at infinity in a given chosen affine chart is totally invariant. So it's a quasi-projective variety. Defined over Q, and you look at, D and D are integers, so this one is at least 1 and this one is at least 2. And you look at the Chow variety of curves in P2 with degree at most D. Okay. This is your second parameter space. And so the theorem, which is to be written, is the following. So there exists U in the product of these two spaces, which is Zariski open and non-empty. Zariski open and dense. There exists an epsilon positive, and there exists B, at least one, such that if you take any pair of maps and curves in this open set, the Q bar, then the set of points, of Q bar points of the curve, for which the canonical height of the point is smaller than epsilon, is bounded by this constant B. Okay. So for a general pair of map and curve, there is a uniform upper bound on the number of points which are small in the curve. So in particular, this implies that the essential infimum on the curve of the canonical height is at least epsilon. Okay. So it doesn't give you a solution to the problem, but it tells you that, well, this is something which is not concerned with a general parameter. Okay, so how much time do I have left? 3 minutes, okay. So just let me say a word about how do you prove such a statement. So I'm a complex geometer. In my heart, I'm really a complex geometer. So let's go back to complex geometry and see what you can do. So so there are two main steps of the proof. The first is to use, as for the classical Bogomolov conjecture, to use the arithmetic equidistribution of small points. But in what context? So the context is the context of the work of Johan and Zhang. So you let V to be your parameter space here. Poly D2 times chow of D. And so you have a map. V P2 times P2 to V times P2, which is given by your parameter points is sent to T Ft of P. So you can see it as something which parameterizes a family of maps. And so it gives you a map. So you take L to be O of 1 P2 on this variety. Let's call it X on X. So it's a relatively ample line bundle. And you can do the Néron-Tate construction exactly the same way, but in this relative setting. So you can cook up this guy, HXL, composed with Fn. So if you specialize to fibers, you recover the heights you had for the given parameter you have. And actually, you can do a little better, meaning that if you endow it with an adelic metrization here, you end up with a height associated to an adelic line bundle in the sense of Johan and Zhang over the quasi-projective variety, which is X. So a la Johan Zhang. And so to apply the equidistribution theorem of small points, so you will proceed by contradiction, assuming that in this big, so you take capital C to be the family of curves parameterized by your variety V, and you will assume that there are Zariski dense there. So you want to apply an equidistribution theorem and find a contradiction. And to apply the equidistribution theorem, you need to show that this adelic line bundle, when you restrict it to this guy, it's geometrically big. And so this reduces to a question of complex dynamics. You can reduce it to a question of complex dynamics, and it goes along the way of proving that a given measure is non-zero. So you can do the same procedure here, but in complex geometry, saying that you will have a canonical current here. So it will be the limit, 1 over d to the n. So you iterate and you pull back some Fubini study form of P2, one you prefer. And so the condition to be able to apply the first part of the proof is to show that if you take this guy, so you wedge it with itself, it's not a smooth form, but well, there is Bedford-Taylor theory tells you that you can do that. And you wedge it with your curves, and you push it back on the parameter space V. It gives you a current, and you want that this current has an associated measure which is non-zero. So this is the condition. Okay, so all we do is reduce the question to studying this object. So non-zero implies you can do the equidistribution. And then in one word, this is not the hard part. The hard part is the next one. How do you find a contradiction? You show that the support of this guy contains an open set, a Euclidean open set, open subset of V of C. Well, and all the machinery from equidistribution prevents you from this to happen. Okay, and I think I'm going to stop there.
Any questions for Thomas?
So I have a question about
Sorry, hang on.
I have a question about the small epsilon and the capital B. It's compatible by capital D and the small d?
Hopefully, yes. No, for us, it's just you assume that it's not true. And so you assume that you have a Zariski dense set of points in the family of curves, which is with the height tending to 0, and you end up with a contradiction. So somehow not completely. So the thing is that, in fact, here you can compute the arithmetic volume. So you have a lower bound, which is given by the arithmetic volume. But, well, it's not very easy to compute, so I'm not sure.
Thank you.
I'm on my way.
Yeah, so I have a very naive question about the conjecture by Gyokataka and Zhang. So is it known that this condition they give is sufficient so that if you have this Z and G, etc., that the essential infimum is 0?
Yes. So the fact that they commute makes that they have the same preperiodic point in the subvariety Z, so the fact that preperiodic points of Z of G and preperiodic points of Y are dense is equivalent, and it's preperiodic, so they are dense. So yeah, this is the fact that they commute is really crucial everywhere.
Other questions? Thomas, can I ask you a question? In your main statement here, you're taking the Q-bar points of U, but can you use the specialization argument to promote it to say something about preperiodic points on complex curves?
If instead you want just to have points of height 0, then for complex points of U, it works. You just have a, it's a counting dimension argument, but it works. Yeah.
Great. Other questions? All right, then let's thank Thomas again.